we're going here. Let's get, we left off right here last time. All right. We were talking about indexed sums, right? And thanks to Tyler, we finally got this one. We left off right here. Now, I'm going to be giving you these on the test, not the test on Monday. This is next chapter, right? So everything, no, check that. Sorry. We're going to start chapter 2 today. None of that's on the test. But yes, these formulas will be on the test. Right? They'll be on.
So this is on the test? Or not this?
No, this material's on the test.
This material.
Material's on the test, and these formulas will be there. So you don't have to memorize the formulas.
All right.
But we're not going to cover anything really new today.
Okay.
But we're going to cover this next problem. This next problem is the previous couple of slides applied. Okay. Now, is the previous couple of slides applied? Now, question. We're doing from 1 to 10. You notice that all of our formulas, summation formulas, are always from 1 to whatever number. Down here was how you handled it when it was something besides 1 at the bottom. It was 7 down here up to 20. So we're going to apply 3 of these formulas here, because we saw a property that the sum or difference of sums is the sum or difference of the sums. Right? What's this? The sum of an plus or minus bn equal the sum of an plus or minus the sum of bn. We saw that property last time. Okay, we demonstrated it in this example here, right? That this difference up top was the difference of the sums, and that was kind of like how we did that. Went through that last time. Evaluate. So this is going to be what? Be sum I equal 1 to 10, 3i cubed, minus sum I equal 1 to 10, 2i squared, plus sum I equal 1 to 10 of 4. Now, another property is that this 2, or this 3, this 2, and that 4, any factor that does not depend on I, a factor, something that's multiplied, that does not depend on I, we can bring past the summation sign. So this is going to be what? 3 times the sum I equals 1 to 10 of I cubed. We have a formula for that. You see, we didn't have a formula for this business up here. Right? We have a formula for that. Minus 2 sum I equals 1 to 10 of I squared. We have a formula for that. Plus 4 sum I equals 1 to 10 of 1. And we have a formula for that. This is the way I recommend breaking this down. Formula time. For I cubed, back, here's our formula right here for I cubed, right? So it's going to be, okay, very careful, this is why I messed up last time. 3 times n squared. What is n? 10. 10 squared times n plus 1 squared. 11 squared divided by 4. All right. Minus 2 I squared. We're going to have n, 10. N plus 1, 11. 2n minus 1. So that's 2 times 10, 20, minus 1 is 19. All divided by 6. And that's going to be interesting because none of those factors on the top are divisible by 3. So we're going to have a fraction there. And then the sum is going to be plus 4 times the sum of 1 10 times. Well, I'll just go up here. It's n. If you add 1 10 times, you get 10. I recommend being very careful here. Very careful. And you will have a calculator if I ever ask you to do something like this. Or I'll just have you leave it this way. That's another fact. That's another way I do things is that in cases that I don't allow you to use a calculator, and I think there's one test that there's no calculator, you leave things unsimplified. I want to see that you know how to plug it and use the formula right. And we leave the onesie twosies. No, I'm never going to ask you to do extensive arithmetic, without a calculator. Okay. Put this way, not if you're doing it the right way. Not if you're doing it the right way. So let's look here. We're going to have 3 divided by 4. What's 10 squared? 100 times 121. Let's leave that alone a second. Minus, let's see here. Those cancel. 121 times 19 divided by 3. Plus 40. We've got a little simplifying we can do here. 4 goes into 125 times. So you can bring these numbers down. Right? You can bring these numbers down. All right. Now, as I said before, 3 doesn't go into 3 doesn't go into 10, doesn't go into 11, doesn't go into 19. So this is going to be some kind of fraction, right? So we're going to have, let's bring our calculator out. There you go. Actually, here, let's go here. Move that all to the left. There you go. Yeah. Let's clear that. That's what we were doing last period. Be glad that you're doing that class, right? Second, quit. Clear. Let's do some math. 3 times 25 is 75. So 75 times 121. All right. Then we're going to have, I tell you what, let's just do that. Let's see what that equals. 605
Way bigger.
Oh. Oh, I didn't do 75. Sorry. 75 times 121. Yeah, a little bit different. 9075. This one here, gonna be a little bit sticky. 121 times 19. So you're gonna have 121 times 19, 2299 over 3. Plus 40. 40 is 120 over 3. So we got to add those fractions. And to do that, we have to multiply this first one on the top by 3 and on the bottom by 3 to get a 3 in the number. Yes?
How did you get 120?
How to get which one?
120 divided by 3.
Oh, the 40. Yeah. Because, yeah. The reason why is I need a 3 in the denominator here to add these fractions.
Oh, okay, I was like,
Right. So I multiplied top and bottom by 3. Here, maybe I should put this G like that. And you ask me that every single time. If there's something on here and I do too many things in one step, call me on it. Because I may be wrong. But I want to make sure you understand, right? You're very welcome. Thank you for the question. So now, we're going to go to our calculator and add these 3 numerators together. We're going to add 9075 times 3 minus 2299 plus 120 You know what? There's something that's not settling right with me. We'll see. Something is not settling right. Plus 120. Hit enter. Now, I want to see something here. 10 squared over 4. That's good. 10, 121 times 19. I am checking. Oh, here we go. Here's our problem. Here's our problem. Tyler, where are you? At 19? This is supposed to be a 21. So we got a bunch of changes. That's a 21. That's a 21. So this number here is actually, the whole number is going to go, which is good. We don't have to do this 3 business. Oh, dear. So I always go back and check my work when I see this stuff, and there was something that I didn't like there. I'll tell you what I didn't like there is it didn't come out to an integer. So that and that give you a 7. So I have here 121 times 7 plus 40. Right. Now, convince yourself that if you just put integers into this quadratic or this cubic, if you put integers into that cubic, you're going to get integers. They're going to be big, but they're going to be integers. So I shouldn't have had a 3rd in my answer. So I knew there was a mistake there somewhere. All right, let's try this. $9075 minus. Oops. There you go. 8268. That's right. And we'll put that. When you do a problem like this, and there are so many little arithmetic operations, always go back and check your work. Even if you think you're right, go back and check your work. Right. That's very important. But this right here is actually nothing new from the last time. It was these things, these two principles, more or less these two problems put together. Okay. Because here you're adding and subtracting, and then here you're plugging into the formulas. That is all. Oh, this. Now I believe I got this from Facebook. There's actually a group or page on Facebook called Art of Mathematics. It's a website. It's a very mathy people know about it. But we have, did you notice back here, and I mentioned this last time, this squared is that. So this equals that equals this squared, and that inside equals that. Okay. So over here, down a bit. These are our i's right here. I equals 1, 2, 3, 4, 5. Okay. And so I cubed is 1 cubed. If you have little cubies, a 2 by 2 by 2 cube would be 8, right? A 3 by 3 by 3, 27. 4 by 4 by 4, 64, and so on. Well, what if you took this little cube there and put it in the corner? This has 2 layers of 4, right? How about if you put 1 layer of 4 right here, and you broke up the other layer of 4 here and here? So you can take this little block and wrap it around that. You can take this block of 3 by 3, and there's 3 nice equal 3 by 3 cubies there, right? 4 by 4 by 4, there's 1 4 by 4, there's another 4 by 4, another 4 by 4. You take the remaining layer, cut it in half, and it fits in. 5 by 5 by 5, you have 5 layers of 5 by 5. What's the point? The point is, if you added all those up, it would be the same number of cubes there are here. This is a flattened version of those 5 cubes put together. Well, what is this? That is the sum. That's 1 plus 2 plus 3 plus 4 plus 5, which is the sum I equal 1 to 5 of just I. But this side here is also that. That side is the same thing. Because look, you got 1 plus 2. How long is that side? 1 plus 2 plus 3 plus 4 plus 5. That's 1 plus 2 plus 3 plus 4 plus 5. So that is this. And so since this is a square, its area is one of these squared. So the sum I equal 1 to 5, which is this part, squared is one way of adding up those in the middle. But notice that equals the same number of cubes in all of these put together. Because all these cubes put together got flattened out into that. So the sum of the cubes equals the sum of the numbers squared. That's a geometric interpretation. That's not on the test. Don't worry about it. You didn't understand it. And here's the algebra behind it, which comes off the other slide. This is the cubic formula. This is the one. This is sum I equals 1 to n of, or I have k here for some reason, of k. All right. Don't worry about that. Last time I talked to you about these people, right? Dale and Raylene Larson, very, they sacrificed greatly. Their lives would have been so much easier if they never came to YC. Because they worked so hard when they were here. And he was a preacher in Omaha, and he helped get York College for the Churches of Christ. And what they did is the town of York went around looking for a denomination to take over the campus after the other denomination left, the United Brethren. And they saw that the Churches of Christ run a lot of small colleges pretty well, and that impressed the city. And so we got the campus. They pretty much gave us the campus. All right, that's oversimplification. Let's go to chapter 2. Starting here will not be on the test. All right. Now, anyone last time who did not get chapter 2 slides? Okay. Functions and graphs. Going to be a lot of repetition here, and some of this, I promise you, I am going to put on the. I'm going to put on YouTube myself for you to watch on your own. You may or may not like that, because we're still going to have class. It's just that the review part, I'm going to leave on more of that on your own. But functions and graphs. Yeah.
Wait, so for the review, is it going to be like during, or is it going to be after we finish chapter 2?
Oh. I meant, no. There's not going to be a test review. Okay. I meant review material that's in chapter 2. It'll be after the tests for chapter 1. So in other words, there's a lot of review material in chapter 2 that had half of you meeting and half of you rolling your eyes. I'm putting that probably in more and more in separate videos to allow more class time on the harder material. Because it makes no sense to run through it all at like the same pace, and so much of it is screwed up. All right, so I'm going to be making videos more often. I got one to make this afternoon for another class. I might make 2 in chapter 2, because functions and graphs, you should be very familiar with functions. Right. Someone at your level. So, okay. I've been around long enough to purpose. My wife accuses me of putting my conclusions first. All right, functions. This is something I probably should have put in an introductory video, but function is just a formula that assigns every value in some set at most one value in another set. Okay? At most one value. So if I have a set X, not every value in the set X is going to get assigned somewhere. It's like not everyone's going to get picked for the team. But if you get picked for the team, you get picked on one team, not 3. Okay? So you might go on the orange team. You might go on the red team. Sorry, Tyler, you didn't get picked. Okay? So you went to one team. You went to one team. You didn't go to any team. And Ottavio, you went to 3 teams. Now, 3 teams want you. He's that good. Right? Now, you can't go to 3. Now, there are a lot of things in ordinary life that you expect one answer on that involve a formula. Right? That involve a formula. You want one answer. Right? How old are you? I'm 37. I'm 18. Right? I'm 4.5. Remember that? Remember when the half really counted? Remember that little? What you don't expect is if I ask Iago, how old are you? And he says, 17, 64, and minus 23. Right? You don't expect multiple responses. You put one name in, you get one age out. Right? I go down and buy 102 by 4s at the lumberyard. I expect one price. So these are the people in the blue box that are picked for a team. Not everybody in the red box or the red oval gets picked. The ones that do get picked are called the domain. Right? These are called the domain. Right? In the answer for the age function, you don't have negative ages. So nobody tells you they're minus 7 years old. Right? So minus 7 is not in the range, we say. So over here, you might have points that nobody is sent to. That's almost like saying there's a team that nobody's picked for. All right, so the set of numbers that get a number sent to them are called the range. Okay. All right. So the domain are all numbers that get picked for a team, so to speak, that get sent somewhere. Range is all the numbers that get somebody sent to them. Now, I may assign you to the blue team, you to the red team. I may assign Gina to the red team. So you and Shai are on the team together, right?
Yeah.
Sorry, Tyler, not on a team, right? But it's okay if 2 people go to the same team. It's just like it's okay if 2 people are the same age, right? He's 18, she's 18. That's a happy meal. You don't want someone with multiple ages. All right? So finding the domain of a function. All right, this is, so just, whoa. I deleted the function. It's pretty funny. It's not funny. What I do is I take my slides every semester and I delete all the writing. Sometimes I delete too much. So anyway, here is the function. So f of minus 2, so that is what I deleted, I apologize, means you stick minus 2 in everywhere for f. So this is going to be everywhere there's everywhere for x, excuse me. Everywhere there's an x here, you're going to put a minus 2. So we have a minus 2 up in the top for x. We're going to have 3 times minus 2 squared minus 4 times x, which is minus 2, plus 1. Everywhere there's an x, you stick what's in here. This should be heavy review. You should be saying, Miller, I did this in 8th grade. Some of you did. Right? So this is going to be minus 2 on top. 2 squared is 4 times 3 is 12. Minus 4 times minus 2. So 4 times minus 2 is minus 8. That's plus 8. Plus 1 is minus 2 over 21. This is one we're going to have to do. The second one is one that we're going to have to do multiple times. F of minus x. What that means is everywhere there's an x in my original function, I replace it with minus x. And whatever happens to x in my original function gets multiplied by 3 or squared, that's going to happen to minus x instead. So it's going to give you usually a new function. So we're going to have minus 2 up top, or excuse me, minus x up top, 3 times minus x, minus 4 times minus x, plus 1. This is minus x up top. Now, that's how. Very important. Minus x quantity squared is not minus x squared. Right? Minus x squared does not equal minus x squared. Very common mistake. Minus x squared, like that, means minus x times minus x. The negatives cancel, and that equals a positive x squared. So when you take something with a negative sign in front of it, I may have said this the other day. I know I said it more in my class. If you take something with a negative sign in front of it and raise it to an even power, that means you're multiplying it by itself an even number of times. That means the negative signs will cancel in pairs because it's an even number. And you'll wind up with a positive value. So if you take a negative number to an even power, it becomes positive. So minus 2 squared becomes 4. Minus 2 to the 4th becomes 16. If you take a negative number to an odd power, minus 2 to the 3rd power, that's negative 2 times negative 2 times negative 2. 2 of the negative signs cancel, but you have 1 negative sign left over. So when you multiply the 2 times 2 times 2, it has a negative still. The point here, this is 3 times x squared. 3x squared. Now here I have a negative, another negative in front of the 4. So it usually produces a different function. In fact, if it produces the same function, we're going to see coming up here, if it produces the same function, we call that an even function. The graph is going to be symmetric about the vertical axis. We haven't gotten there yet, but we're going to. So if this function here turns out to be the same as the original, after plugging in minus x for x and simplifying, if you get the same thing, that is called an even function. It's going to have the property that the graph is going to be symmetric. So it's going to be like symmetric about the vertical axis. If you reflect it about the vertical axis, the graph doesn't change. Right? But we don't need that here. Down here, find the domain. What's the domain? The domain is all the numbers you're allowed to plug in the function. The domain is what's in the square. rectangle, right? So suppose you have a cell phone plan that gives you 500 minutes a month. Now, some of you have unlimited or whatever. Sometimes you have people that are prepaid plans, track phone or it's called Straight Talk, from Walmart or whatever. Right? And you buy a plan that gives you 500 minutes a month, and then there's an overage charge for every other addition. Right? You don't walk into Walmart and say, "Hey, I need a plan for minus 300 minutes a month." Right? Minus 300 is not in that domain. I need a plan that will give me 500 minutes a month. Right? We got that. 1,000. Minus 300. We don't have a plan for minus 300 minutes a month. It's almost like you're selling Walmart minutes. Right? Right. So moving on. Oh, we didn't answer the final question. Find the domain. The reason why I went back here is there's numbers that are not going to be in the domain. The minus 300, not in that domain. That problem. What you look for when you have a function are numbers that make things undefined, or a number that makes a negative under a square root. Right? So one common approach is you start off with the domain equaling the set of all real numbers. And then you look for problem numbers. What do I mean? Here. Here. If this is my original function, what is going to create a problem for that function? If I have a 0 down here. All right. So I start off with all real numbers. I'm going to throw out the numbers that make the bottom 0. There may not be any numbers that make the bottom 0. But if there are, we throw them out. So 3x squared minus 4x plus 1. Does that factor? Oh dear. Turns out that it does. So, remember the zero product rule? We did the first day of class, right? Zero product rule. If the product of two or more factors equals 0, at least one of those factors has to be 0. There's no way to multiply a bunch of stuff together and get 0 without some of the stuff being 0. Because all of them are different from 0. When you multiply them together, they may be big, they may be small, but they're not going to be 0. So we need 3x minus 1 equals 0, x minus 1 equals 0. So this is going to be 3x equal 1, x equal 1/3, x equal to 1. So these make denominator 0. Make the bottom equal 0. Therefore, not in the domain of f of x. All right? So what is the domain? The domain is going to be all real numbers except 1/3 and 1. So domain, this is one way of writing it, is the set of all real numbers except 1/3 and 1. Another way of writing that, same, or you could write that as a union of intervals. So you could say minus infinity up to 1/3, union 1/3 to 1, union 1 to positive infinity. What is that? That's another way of saying on the number line, if that's the whole number line, I don't have the point 1/3, and I don't have the point 1, but I have everything else. All right. This is the graph of the solution set. This is another way of saying the solution set right here. Right? Or you could write it out in words. Right? Or let me tell you what you can't do. That's not a set. Your answer must be a set. You must describe a set. Right? That's true for domain or range. All right. So we took a look at the places that made the denominator 0. That makes that undefined. Those cannot be in our domain. It's like saying, asking Walmart how much minus 300 minutes a month is on their cell phone plan. Find the difference quotient. This is actually important down the road. All right, this is something that they want you to learn now. It involves what we've been doing. This is the difference quotient for that particular value. So the difference quotient is going to be f of, well, you already got that, right? So what is f of x plus h? F of x plus h is the original function with x plus h plugged in everywhere there's an x. So over here, let's go on the side. F of x plus h is going to be squared. If I plug x plus h into x squared, that's what I get, and I add 1. So this is going to be that minus f of x divided by h. Now you're never going to be able to leave it like that. Always going to have to simplify. So this is going to be big long fraction sign. X plus h squared is x squared plus 2xh plus h squared. Plus 1 minus x squared and minus a 1. Distribute that minus. So you're going to have minus x squared minus 1 all divided by h. And we have some things that cancel. Let people catch up. We're almost done. X squared minus x squared. Right? Plus 1 minus 1. So this is going to give us what in the top? 2xh plus h squared divided by h. Well, I'm not done because the numerator has an h on both terms. So I can factor that off. Factor an h off of each term on the top. Those cancel. That is the difference quotient for the function x squared plus 1. Right. Now, some of you are going to go on down the road, and you're going to go to graduate school. Some of you are going to get maybe one of the executive master's degrees that are out there, executive MBAs. They don't require calculus. Almost every business program, undergraduate business program in the United States at bigger colleges requires calculus. UNL does. Where I taught for years, University of Florida, business people had to have 2 semesters of business calculus. Every business major. 2 semesters of business calculus, which is basically the regular calculus without trigonometry. What we got here? We'll do that one next time. So why don't we call it there? Hey, hope you guys have a great weekend. I hope you get to spend a lot of time in places where you don't have to wear a mask. Okay, that's my prayer for everybody, including me. All right. God bless. I will be in my office this afternoon. I have office hours on Monday as well. If you have questions, just check the office hour list. Be happy to help you out. Uh-oh.